Yeah, so it's me and Sage. So it's me and Sage back over here at the office today, and looks like I'm gonna settle a trip and fall case today. I gotta send over the paperwork a little later. Thank you. And that's what's going on right now. Yeah, I gotta get the internet services set up. And I'm gonna take her over here and get something to eat from the deli real quick. But I gotta make a few phone calls. Don't put your hands on the paintings, okay? You're not supposed to touch them. You're supposed to look at them. That's what art is about. Art is about appreciating, not touching. You know? Not unless you're making the art. Which I gotta bring y'all art over here. The art that you made me. I'm gonna put that in here. But yeah, that gumball machine, we were gonna have I was gonna surprise you with that gumball machine, but yeah, well, it doesn't have the glass globe, so that's the problem. The globe didn't come with it, and the stand was messed up, so they're gonna send us another one, and I'll get it fixed when I gotta send that one back though, so I gotta package that back up. And the table is coming today, and let me move this stuff out of the way so you can sit down. We're gonna go get our food, and we're gonna come back here. You hear me? Yeah, don't touch that. Don't touch that. We're gonna get our food, and we're gonna come back here. We're gonna sit down, and you have an idea what you want to eat? You want to go get a menu first? Let's go get us a menu, and then we can kind of get an idea of what we want to eat. What you think? All right, cool. One thing for certain about this office is that it definitely is a lot colder than my office upstairs, which is cool. I'm gonna have to get a throw for that couch, but right now we're just working. Isn't that right, Sage? I haven't got all my furniture in, but we're still doing work. Still working. It doesn't stop. I'm really bouncing back and forth between handling these cases and getting stuff for this office. Like my table just came for the front area, so I'm probably gonna put that together really quickly because it's like 4 o'clock. It's like 4 o'clock right now, so I'm gonna take some time and get that together. And I tell you what, since I moved to this front area, I have just been meeting people left and right. I mean, I didn't realize this front area was this busy, because I always parked in the back and just dealt with the people who, you know, kind of dealt in the work suite area. But now, you know, this is turning into something else, turning into something new. I'm really excited about it. I gotta pack up this bubblegum machine. I think I'm gonna put a couch back here. I think I may put a couch back here, or a love seat, and maybe another chair. I saw a chair not too long ago, but I was trying to get him to come down on the price of it, because I was like, I'm not paying that, it's too much. So I'm gonna wait and see if it's still there in like another few days, and then go back and say, all right, let me get that chair from y'all, because it would have really went nice in here. It would have fit well. Yeah, it really would have fit well. I might go back and get it if I can get him to come down. I'm talking about rock bottom prices, you know. What's going on, guys? It's the Big Rig Bull Texas Truck Accident Lawyer Reshard Alexander here again today on episode 22. We're going to talk about onboard electronics for commercial motor vehicles. So we're not talking necessarily about passenger cars or anything. We're talking about the electronics principally that you will find on an 18-wheeler or a tractor or a commercial motor vehicle. Okay? So we're not really going to cite law and everything like that today. It's mostly about the mechanics dealing with accidents on the roads and the equipment that is supposed to monitor and prevent them. So let's get started. So essentially, there are two types of onboard electronics. Okay, there is vehicle equipment, which is considered part of the commercial motor vehicle, and it affects the performance of the commercial motor vehicle. And then you have fleet and operations equipment. Fleet and operations equipment principally is to monitor, assess, and evaluate fleet performance. So we're not talking about a single truck. We're talking about a wide plethora or a wide array of different vehicles that are under the operating authority of one motor carrier or one owner-operator. Okay, so vehicle databus communications were established by the Society of Automotive Engineers. These standards, J1587, 1708, and J1939, were the standards that essentially allow various manufacturers to put together different components to service commercial motor vehicles without direct wiring. Okay, so this is the first time when this happened with the Society of Automotive Engineers. This was the first time essentially that you could have subsystems of engine parts that work together, not just the engine, but the entire network of the car, or I'm sorry, not the car, but the commercial motor vehicle, that didn't have to be wired together. So when I say that, what I'm essentially saying is we're talking about the subsystems that were manufactured by varying companies. And so we're talking about, like, for example, the transmission, the engine, the brake system. All those things now could work together, and they didn't require direct wiring. This kind of changed. This was like game changing. And so along with that, there's a power line carrier that's connected from the tractor to the trailer. And this power line carrier also has allowed 18-wheelers or tractor trailers to be monitored in a much more safer way, because now the trailer can alert the driver to possible blowouts, possible tire failures, possible rollover situation, or a jackknife situation. Okay, so the power line carrier, like I was just saying, it extends the the VDC, or the vehicle data bus communications, to the trailer as well, and it's commonly observed in the anti-lock braking systems. Yes, where you commonly see, like I just brought up. So mentioning the ABS systems, or the anti-lock braking systems, let's talk about that a bit. Okay, so anti-lock brake systems have been mandated in 18-wheelers or tractors since 1990. They are pretty much composed of a combination of sensors and modulators that monitor wheel speeds and prevent brake lockup. When you combine the anti-lock braking system with traction control and the anti-lock brake system combined will prevent excessive wheel spin and low acceleration events. Okay? Now, this excessive wheel spin can cause damage to the axles and the drive shaft of the commercial motor vehicle, which is why you need traction control. Okay? Because what it essentially does is it transfers the power to other drive wheels, and it commands the engine to reduce engine speeds. To reduce the engine speed so that the wheels don't completely tear the car up. So the other thing is, so we have the anti-lock braking system, we have the traction control, and we have a stability control. All three of these work together. Okay, the stability control systems, I mean, it's common sense. Just what it says it does. I mean, when you combine this with the anti-lock braking system and the traction control systems, it is essentially additional sensors that monitor wheel rotation and the steering input. And anytime there's a potential loss of control on a tractor or 18-wheeler, and it's detected by the stability control systems, it results in a reduction in the engine speed and application of selective braking to a particular wheel, meaning that it can automatically kick in and say, okay, we're going to slow this down and we're going to turn this particular way or stop this particular way so that this truck will not turn over. Okay. The other thing I wanted to talk about very briefly was tire monitoring systems. So essentially there are two tire monitoring systems. There's the mechanical systems, which are typically attached to the valve stem of the tire. It helps reduce underinflation. You can usually just look at it right away and tell, if it's underinflated, overinflated, or whatever. Then you have electronic tire pressure systems, and those systems are usually attached to each wheel, and they transmit data to the cab or the mounted receiver, and it alerts the truck driver to blowouts, tire failures, and incorrect inflation pressures. Lastly, I want to talk about automatic tire inflation systems. I mean, none of this stuff right here, even the automatic tire inflation systems, will not prevent you from having to do, your inspections and whatnot. I mean, it should be common sense for most truck drivers, but it needs to be said. But with automatic tire inflation systems, you use compressed air from the braking system on a commercial vehicle and a system of valves that is plumbed through the axles and the wheel ends. And so anytime that the system detects that the tires are underinflated, the air is pumped through valves through that system to reinflate it or to keep it at a certain pressure. So this wraps up today. Like I said, this has I'm not going to say it doesn't have anything to do with truck accidents, because it definitely does. But this is not law necessarily. This is really about trying to dive into the mechanical side of understanding how trucks actually work. So I hope this was helpful to you. I'll be back again tomorrow to start part 2, where we will talk about fleet and operations equipment, and we may have to wrap up a bit of the vehicle equipment because I don't think I talked about transponders and some other things. But I'll be back tomorrow. You take it easy and have a nice day, nice night, wherever you are.